So, hello everyone to this more ad hoc occasion today, where we are going to improve the error recovery of the parser. More precisely, we had a discussion today and someone made a typo where they tried to use the OR operator that you're used to in the C family of languages, but for us this is not the OR operator. This means basically nothing. For us to write OR, we would do this, and the error message is kind of misleading because if you write this, you would get an unexpected input and you would get an expected token that would say close parentheses. And we have a bunch of these where you're used to it in C#, in C. You might argue that since we are making a language targeting C# people, that we should accept these as valid operators, but for most of them I could argue against it, especially for things like the percent and the exclamation sign. But let's not get into that part of the problem. What we want to do is actually tell people, hey, we see that you want to do this, but in this language you actually do it like that. So as far as I know, Rust does quite a bit of this, where they try to recognize a few constructs that are familiar in other languages, but it's not actually Rust. For example, a very simple warning they do is that they tell you, hey, you don't actually need parentheses around your conditions in if and while constructs. Now, the goal for today is to be even simpler. These tokens that I've listed here, the percent sign, the double pipe, the double end, and the exclamation mark, are all currently tokens that we do not use for anything. So given that we recognize them in the correct part in an expression, for example, on the parser level where we expect an OR keyword, we could just also consume this double pipe and report to the user, hey, this isn't how you do it in this language. But we would still parse the tree and would give more information to the user. First off, a more elaborate error message telling them how to correct it, which is always welcome. At least that's what I see when compilers do this. And we would also get a nicer tree shape. For this occasion, we already had the ability for the compiler to visualize parse trees like this. This is the hello world that you get. And yeah, this is a bit elaborate, but this is how our parse trees look. And I exposed it in the CLI tool, so we can finally use it for files. You just specify which file you want to graph out, and then you get a dot or graphviz or whatever output format this is called. Yeah, Binto is mentioning that we not only want to report them and tell the user how to fix it, we could actually provide code fixes themselves, which is correct. We can eventually do that. We'll see if we have time during the stream, but yes, that's a very, very good point. So I would say let's get started. Our first order of business will be lexing these tokens and storing them in the tree. First of all, let's actually reproduce the error. So we have this program here. Let's minify it a little so the syntax tree is not that elaborate. So I'll try to throw away everything that is not actually needed. And let's visualize this. So if you look at the tree, it's still going to be a a bit too much, but hopefully it will fit on one screen here. Okay, sort of. So what we have here is we have the if here, we have a literal expression, but then the parser kind of gets lost here. You can see that it finds the literal and it doesn't find the closing parentheses, so it tries to move on here and essentially appends a bunch of unexpected expressions here as a list to you know, not lose these tokens, and to be able to reconstruct a tree for the user eventually for formatters and such. We never want to lose tokens here. Kuino is telling me that I don't need an if, I can just make a value. That's a good point. So we could go even further and do something like this. This should be valid as well. So this tree is even smaller to demonstrate the problem. Okay, that works. So what we would want to do here is actually inside the expression statement, we would construct a binary expression, just like we do for OR expressions, but mark the operator, the double pipe, that this isn't actually the correct operator to use here. So the tree shape would be identical to the correct usage, which let's try to compare. Let me run it through here, and you see that for the correct syntax, you just get a binary expression here with two literals being ORed together. So let's start by lexing these tokens. And the first order of business will be to register the token types. So that will be, actually that will be the API syntax. And it's going to be a token kind. And let's go to the operators. We have them in a bunch here. Actually, let's go to the end and sort of start a new kind of section of operators that we will call something like legacy, or maybe C style or something. Let's just call them legacy. So this would be legacy remainder, which is going to be the %. If anyone has a better suggestion for names, please do. For now, these will suffice, I would say. So we will have a legacy OR, a legacy AND, and a legacy NOT. So with these, I think we only had 4 here. Yes, we did. And that's gonna be enough for today. It will be easy to expand on later. So let's lex these, which is fortunately the easier part. The lexer is just a few gigantic functions here. I believe we don't use the exclamation mark for anything, but let me check. We use it for not equals, but we don't use it for not. It's a bit of an inconsistency, but that's also what Python does. So we even have a note here, and let's actually put the logic below the note. So this is legacy not done. That was easy enough. And 3 others to go, I believe. Yes, one is %. I don't think we ever use %. Nope. So that's going to be pretty simple. By the way, if I mix remainder and modulo, please remind me as well. I believe that C uses % for remainder, not for the modulo operation. And as far as I know, Python does the exact opposite, but I'm not sure. So please do correct me if I misuse it. I don't think we use AND, and I don't think we use pipe, so okay. That's wonderful, because that means that we can do this. And we'll leave what to do here, because a single ampersand sign would be binary ending, and the single pipe character would be binary ORing together. But we don't have the equivalent operators in our language yet, so I won't bother adding the legacy token for it, at least for now. We will only do this for the things that we already have existing. Well, not binary, sorry, it's bitwise it's called. I mean, technically it's bit binary as well, but that's not saying a lot. Okay, I think it's correct. So if we go back to the wrong example here, I hope I can undo here as well, so I don't have to rerun the visualization. So what we should see here is at least the two tokens getting merged here. So we should see on pipe instead of two. We actually get a crash. Oh yeah, because we need one more thing for each token that has a predetermined text, and we don't want to allocate the text for it. And that's what take basic does. We actually want to be able to turn the token kind itself into the text representation from a function here, and I think that's in syntax facts. Yep, that's right. So we just need to add the new token kinds here, and I tend to use the same ordering. So we'll do that here. So we want 4. And finally, it's not. And with that, we should finally parse again. Good. And let's see. So hopefully, yep, we have it merged. It's still in an unexpected statement, but it's one token, so we can handle it as one token during parsing. So I'm going to commit this. I'm already on a separate bench. And now we can actually move on to the more exciting part, which is parsing. And it's going to be exciting because it's been a while since I worked on the parser. I only have vague memories. So first off, if you're not familiar with our parser, the expression parser is actually table driven, which means that we have a huge precedence table. I think it's in parse expression. Yep. Where we have a huge table of precedence here, where we just specify that on level 0, which is the lowest level of precedence, all the way to level 10, which is atomic expressions. We have either custom parsers, like parsing a parse level expression, or call level expression, or even atomic expressions are kind of custom. And we have these combinator style parsers, where we just say it's a binary left associative level with these operators, and please handle them automatically. And this is what's being done with the or and the and keywords as well, which we will need to change a little, obviously. So we also have a couple of tables here at the top, which help drive the parser's error recovery. We list all the tokens that can start a certain thing. For example, a declaration can be started by these keywords. These are the visibility modifiers. These are tokens that can start an expression. And in fact, we have just specified one that could technically start an expression. And that's going to be the legacy not. Even though it's not a legit operator, we wanted the parser to be smart enough to try to recognize that the user probably meant a not here. So we will include it in the error recovery table. Okay, and let's try to figure out how we are going to include this information of legacy tokens in the precedence parser. Let me navigate back. Whoops, that's the wrong file. So here's our precedence parser. So we'll need to add, or rather modify, 4 things here. So first off, we have the not keyword somewhere. I do not see it. Oh, it's here. We need to add the legacy not operator here. We need to add the and or legacy operators here, and we need to add the percent on the same level as the modulo and the remainder. Now, these are pretty generic methods. These just generate a closure that is able to parse that given precedence level. Binary left in particular is just parsing anything that is a binary operator and is left associative, and you specify the operators here, and it will sort of parse for you and fold the tree in the proper direction, and it unfolds left recursion into loop. So this is so we don't have to actually write it in line each time we have a binary left associative level in the parser. And what I want to avoid is writing custom levels here that would sort of say, hey, there might be legacy operators here. So we could either have these methods take a list of legacy operators as well, which I'm not a fan of, because this would not only touch binary left operators, but it would also have to touch the prefix level, which I'm not a fan of. Or we could do something like do a check on the operators when we consume them. We just say, hey, this is if this is part of a legacy operator set, then record the error here. I'm not quite sure which one to do here. Neither of them are particularly nice, and neither of them are easily localizable into one place to change. So we could also do it in advance, but it's kind of janky. We don't really want to do that for each token. we kind of know where we expect them. So we might just actually stick with modifying these precedence level parsers. Give me a minute to think about it. So what we could do is, for all of these higher level methods or higher order methods, we could introduce another set of parameters. This would obviously become a non-params parameter, which is unfortunate because it's less nice, but it's whatever. And we'll have another set where we would specify the legacy operator and what should come instead. What we could also do is not to do this on a parser level, but actually do this on a parse tree level or some other kind of check after parsing. But I'm also not a fan of that, because then it will not be part of the parse tree, and what I would like is that these syntactic errors, while keeping the parse tree shape nice, would already manifest in an error even at parse level. So what we could do is create a helper structure here. My convention is that I almost never use row tuples. I always like to name them. So what I do is I create a private read-only record struct, and we can name it something like legacy token is generic enough if we ever decide to do this with other things. And we would include the token kind of the legacy token, and we would include the modern variant, or rather the correct one. I don't know what to call this. Replacement sounds fine. We could also have a global list of legacy tokens again, and jump on them on advancement, but I'm not a fan of that, because then we would report the replacement as a correction even where it's syntactically invalid to write or. So I don't necessarily want to report it here that, hey, you should write an or instead, because no, you shouldn't write anything here. So we're just going to expand on the expression parsers that actually require this change. So let's go back to the parse expression function and let's take a look. So the binary or operator needs to change. So let's go to binary left. Let's go through methodically and change each one of them. So I'm actually going to remove the documentation header. Let's try to keep it and update it. can't type today. And we could definitely default this because we don't really want to specify this for each precedence level. Definitely not. So I don't know if I wanna default this like so. Maybe it might be nicer to do an array.empty. Some performance wizard will tell me that this is wrong and it's nicer to do a null check each time. I don't know. So if the operator contains this, then we want to do this parse, but we also kind of want to do the same logic if the legacy operators contain it. So we will do an else if for now and see if we can factor out the construction logic. Not that it really matters because it's not a lot. Okay, so contains is not the best. We could use the link version of contains. Doesn't it? Oh wait, it takes a comparative, so we could do any. And for now, we're just going to copy paste this logic blindly and do a to do here. Maybe we could do something like throw for now. Okay, and let's go ahead and modify every other function like this as well. So we have prefix done, we'll have to do the binary left associative parsers. I'm going to copy the documentation. I'm also going to copy the defaulting, and well, if it doesn't contain it, we break here, but we don't necessarily want to break because we might actually have a legacy operator here again. So if there is one, if there's none, we can definitely break. Otherwise, we can report an error. I'm just going to report the op kind here. We need to refactor this because first of all this is hairy logic here and this is causing duplication, so we need something like something that reports back that it's either a proper operator, a legacy operator, or neither of them. So we might write a utility function to do that for us. But not for now. I just want to get the really basic stuff done of modifying each of these parser combinators, because in reality these are just combinators if you're familiar with the term. Haskell people love that stuff. That's where we got the inspiration from, but I'm sure that it's not this is not a novel expression parser design. Okay, so if it contains peak, else if why do we peak twice here? We don't even have a go to here. This is just a right recursive thing, so I'm just going to rewrite this to op kinds. And again, I'm just going to copy paste it here. And I'm going to throw to remember that I have to refactor this. Okay, good enough. Again, this is very janky. We'll have to come back and clean this up. So finally we'll have to address all this crap. So this is easy enough. Let's try to keep the C# conventions. Yeah, this is already pretty freaking tedious. Okay, let's see if we didn't screw up anything, and we can easily do that by just running the syntax tests. Well, this is running more tests than just the parser, but okay, so we didn't screw up anything yet. Now let's try to actually modify the parser and get this example to parse, or at least not parse, but for now we just throw. So for the or, we can actually say that let's use name or named arguments here. So legacy, wait, I need a comma here. So now it, hopefully it will tell me, yep, now we can create legacy operators, new legacy token, and we will have a single one here, and we have the legacy or, and what we need instead is the keyword or. So that's pretty simple. For and, it's going to be the same thing. Not, same deal. And there was one more, I think it was, oh yeah, it was the remainder level operators. And that should be it. Now we should get a throw here because we were lazy. But yeah, it's telling us that we use the legacy or operator. So this is pretty easy so far. Now let's actually write the utilities so we don't need to duplicate a bunch of code. And I think what I'm going to do is introduce a new enum. And I'm going to do something like operator kind. Well, that's too generic for the reason. operator search result. So this is going to represent an operator lookup by the token kind. And the first one, the found member, will represent that, okay, this operator on this level is valid and is found. Legacy means that a legacy operator is found. And not found means that we just didn't find in either of the lists. Or rather sets. And we're going to write a simple method that will determine this value for us. Let's actually rename this to token search result. Maybe we will need to reuse this. We'll probably reuse this for not just operators but other kinds of tokens. The most likely use will still be operators. And we will pass into sets. One is going to be operators and one is going to be the legacy operators. And I don't know if I want to take the legacy operators here as nullable. We will probably do that, and we'll get rid of the defaulting in the other methods. So this is going to be pretty simple. Oh, and we also need to provide the searched operator, so or searched token. So this was a simple case. Next, well, a not too complex case, but we'll use link here. And otherwise, by default, we'll just return not found. So what I'm thinking of is maybe we cannot write such a utility function, because if it's a legacy operator, what I also want to report is what it should be instead. So I would love to return the substitution that it should use, and it would make this kind of over parameterized. So for now I'll just scrap this. And what I'll do is I'll try to refactor here. So let's do this actually. So found operator, and if you didn't find it, try legacy. And unfortunately, legacy token is a value type, so we can't exactly call default and determine based on that. But what we can do is get the enumerator and if we can actually step into it, and here we can actually save the alias. Let's actually do that. So maybe we need to do it like so. Yes, and current dot replacement. Yeah, let's not call it replacement. Let's call it, well, let's not call it modern alias. Let's call it replacement op. And this is quite a chunky piece of logic. I wonder if there's a smart way to factor it out, and we might need a tuple returning function for that. And I'm not a fan of introducing yet another one of those. But what can you do? Yeah. This is going to be a rare scenario where I'll actually introduce a tuple. Broken like this. So this is going to be really similar to what we wrote before. But with a tuple return type, so we accommodate all of the usage. So if it's null, it might be easier to check. If it's null, then we just return early, and if we were able to move, then it's going to be this. Otherwise, we can just again return false and null, and it should be sufficient. Now this is an ugly ass function, but I seriously don't have a better idea. So Actually, if search always needs a legacy operator, why the hell would we default that to null? Let's make sure we never pass in null, because then you wouldn't call the function. So now it's just going to be if yeah, this can go out the window. So if we found the operator, but we have a replacement operator, then we know that this is a legacy operator. So what we can do here is check if this is not null, and get rid of all this. And we could do something really simple, like, oh, instead of op dot, well, let's do op kind, and then an arrow, sort of signaling substitution to the replacement of what you should be using instead. And that's what we're going to change to. So it's going to be a nice drop-in list replacement here. So if not found op, then we're just going to break like we used to. And otherwise, if we have a replacement, then let's report an error. Wonderful. This is a nicer way than duplicating all this logic. So again, let's paste this in. Use the proper boolean. Did I replace it here? Yes, I did. Okay. And let me also steal this. So we should still get an error because we have the faulty example running, and it's telling me to replace legacy or with keyword or. Wonderful. Let's see if all the tests actually run and we didn't screw up anything in the parser. We didn't. Wonderful. So let's commit this. And now let's actually see how we can report the error, which is going to be the more fun part. As far as I can remember, we have had a utility to attach a diagnostics to a syntax node, because syntax errors are sort of kept in a separate lookup table for various reasons. It's a sort of look-aside table. I don't even remember what it is exactly, but it's nice because we can just associate any kind of diagnostic here to the syntax nodes without having to have an explicit diagnostic list on the nodes on themselves. Let's make sure that I have a to-do here to doc this, or let's actually document it right now, because otherwise I'll be lazy. Might be a little janky explanation. This will come down in the code review anyway. So, where were we? Oh yeah, we want to associate. We want to associate a diagnostic here. So if you take a look at diagnostic, we always just kind of do the same. We instantiate a diagnostic info, and then we attach it to the given node. Now, a syntax diagnostic info is a little different from the regular API of creating diagnostics. This is because in the parse tree we have to be relative, while everywhere else in semantics we always use absolute positioning and such. Syntax is not that easy because we want to eventually make the parser incremental, which means that we'll always work with relative positioning. And so instead of the usual diagnostic, we'll use something called diagnostic info, which is just a subset of regular diagnostics. It might even derive from it. I want to actually check it out if we do. No, not necessarily. It might just be two completely unrelated things then. Let's investigate and refresh my memory in it, so if they are any related. No, because this is a sealed type, so okay, that's fair enough. So let's create diagnostic information for these cases, and we should. I keep losing myself in the file. It might be the fact that it's a bit too long, but there's also not a nice way to split this apart as of now. Maybe into portions of expression and other kind of parsing, but we won't do that for now. So if the replacement operator is not null, we want to report this as a diagnostic, and I believe that the nicest way to do is to create a utility function for us to do that. So what I'm going to do is write a private void at legacy token diagnostic, which will take a syntax token and the replacement, and this should be all, because then we should be able to create a diagnostic information. And we will probably need a new kind of error here. We have a big list in the syntax errors, I believe it's called. I really don't remember where we have all this. Oh, it's in diagnostics, maybe. Well, the simplest is to just look up a diagnostic report and see where we... Yeah, we do have a syntax errors. Wonderful. So we will create a new kind of diagnostic template. This is ripped out straight from Roslyn, how we do diagnostics, except we don't do localization, as I believe that was a mistake. And we might just have the title as possible typo, maybe. is just a very generic error message for now. We can improve it later, but the tree shape will still stay nice, and that's the more important part as of right now. And we can create a diagnostic info with that. Actually, let me copy that into this new function that we created, if I can find it. It's going to be here, yep. And we need two format arguments. One is the token that was used. So that's pretty easy. That's just going to be format args requires us an object array. Yep. So the first one is going to be the token.text. Yes, I believe. And I really hope that this is the text that I'm thinking about. The text the token was produced from. Yes, that should be it. Okay. And what I wanted to know is that it doesn't involve the trivia, but it doesn't. It will be token.toString to involve the trivia, I believe. And the other one should be the replacement, which is going to be syntax facts dot get token text replacement. And why are you yelling at me? I'm just going to do this, even though this should never be never return a null. But anyway. And then we can add the diagnostic to the token. And so, in fact, I might move this down to the add diagnostic function. So this is going to be the operator, and the replacement is going to be the replacement op. And we can just, we need to unwrap it because it's a value type nullable. Now, for each occasion, we can just replace, and replace. Do we have any more to-dos here? Not that. None that's relevant. Let's see the shape of the tree. We have an argument out of range exception. That's interesting. Oh yeah, because we went forward with the construction. Oh, and it's yeah, the constructor is yelling at me. So what we need to do is go into the XMLs that Draco uses to generate the trees, and it's going to be syntax nodes, I believe. Maybe syntax tree or just syntax.xml. Yep. So we use this huge XML file to generate every kind of node that the compiler uses, and the reason is because our tree is hella complicated. It's a red-green tree. If you don't know what it is, go Google it. There are some nice and simple explanations. And well, it's essentially very hard and cumbersome to write it by hand. So we decided to generate it from XML, just like Roslyn does. So this was also taken from Roslyn. So anyway, let's go to the binary expression syntax and list the new operators that are valid here. So it's going to be legacy and legacy or and legacy remainder And we have one more, which is going to be the prefix. Is it not expression? No. Unary expression syntax, okay. Oh yeah, because we don't differentiate prefix and postfix because we only have prefix. So this is going to be legacy not. Now it will allow us to pass in these token kinds. Wonderful. So let's take a look at the tree shape because that's the most exciting, and voila! It's a binary expression syntax, but now it should probably also report the error, what we don't see in the visualization, but we could actually do something like, we'll actually compile and see what the result is. So let me jump in here and do a compile. And we have an exception because this is an unexpected operator name, which is fair. This is totally fair, and we shall deal with this. First off, I'm going to commit these because we just solved the bulk of the issue. And one might think that we should stop here and not let the compiler continue into semantic checking these, but I believe that's more information for the user after all. We can still check it, we know what they meant essentially. So for the remainder operator, we can also take the legacy remainder. For the not, we can also take the legacy not. And yeah, and for the others, we actually need to go into the binder. I hope this is the right file. Almost. It's going to be here. Okay, here, this is going to be a bit more hairy than I want. So I really hope that these are the only places where we depend on this knowledge. Let me quickly check. I'm looking at the references window on another monitor, so sorry for that. I'm just trying to check if we have any significant places where this is burnt in, but it doesn't look like it, so good. So we could have and or, and we could have legacy and or legacy or, and this could be and or token kind of legacy and. I believe that this should now work. Let's check. Okay, almost. Get assembly with name and token. Okay, this is because we're trying to load system.runtime, but from the CLI that's a bit more complicated. What I can do is actually steal the in-memory references from the test project. That's what I usually do when I compile in the CLI, but I didn't think that I would actually want to run from the CLI today, so I didn't do it in preparation. And we just need to pass in every metadata reference from basic. And let's modify the run function. I believe I'm doing that. No, I'm doing compile. Okay, let's do compile then. Here it is. And we don't need this part. We just need the basic assembly references. Okay, oh, I had a breakpoint here from an earlier session, and for some reason it's thinking that I changed something. Let's just rerun. Spelled as or in Draco. Perfect. So let's try to the other operators as well. So 12 mod 23, and let's do not true, and well, let's do true and then false. Okay, this is nice. And more importantly, it's also type checked. It technically should be able to compile. We don't want that though. We're not doing code gen if there are any errors reported. But it should finish all the way to the end of semantic checking. So it squeezes out every bit of information that we would want in this case. So okay. Finally, I would believe that it would be really nice if we just closed these. And this is because I want to actually recompile the language server, so we get these nice server errors reported in Visual Studio. We have a script for that. What did I screw up? Oh, is this the regular command line I'm running for some reason? Yeah, this is CMD, and I really don't want that. I think it will. Yeah, it doesn't even want me to run. Doesn't want me to run PowerShell scripts. So the reason I needed to close VS Code, otherwise the tool would still be in use. The language server is a .NET tool, and it wouldn't allow us to reinstall it. So now if I open up the project that I prepared, amazing, look at that. This is really cool. So now, if I'm making a typo here, only the relevant error is reported, and it's also telling me how to fix it. It's not fixing it for me, but that's something for another time. Again, let's check the tree shape, which is for me the most important thing. I want to keep the tree shape nice. So you remember that we kind of leaked it off outside the expression after the missing closing bracket, and then we had a random closing parentheses somewhere in the tree. And now we actually have it as a proper tree. Now we don't see the error note here. We don't show it in the tree here. We probably want to read out or somehow show the diagnostics that are attached to certain nodes. But either way, this is really awesome. The tree is now properly shaped, and if an old style C developer or a C# developer accidentally writes the wrong operator, we tell them, hey, this is how you actually do it in Draco. I believe this will be a nice point to stop the stream. Are there any questions? I'll stay on here in the chat and answer any questions that you might have. Pinto is telling me that I just ran GraphViz with the regular OR. Oh yeah, that's true. That's actually true. Let's fix that. Now we have the incorrect one. Let's visualize the tree shape for the incorrect one. But ideally it should be identical, except that we should see the pipe here. Yep. Okay, thank you, Binto. Stupid mistake on my part, but I'm tired. What can I say? Okay, it looks like there are no questions today. It's not surprising, it wasn't a particularly hard task. It was something really simple, but hopefully it's an initiative that we will continue, which is that if there is something that we expect our users to commit repeatedly as mistakes because they come from another language, where they're used to certain other things, but we had a good reason to change it, let's try to recognize that and let's try to help them correct it, or at least help them notice it and tell them, hey, it's done differently here. I believe that syntax errors should be the most beginner-friendly part of a compiler. Well, obviously most diagnostics should be very beginner-friendly if you want a very friendly language, but most errors that beginners will care about in the beginning, at least in my experience, is syntactical errors, because they will miss a semicolon, they copy-paste from another language, and it's really nice if you can just tell them, hey, we know you're used to this, let's transform this to this. And not just beginners, but I believe that this is really nice when you just copy-paste code from a different language as a whole. So thank you everyone for watching, and hopefully we'll have another kind of stream soon where we will continue the match expressions. It's been long going, we've been doing some background work on that, but once that's finished I'll try to get back to that soon and wrap up the semantic checking phase for match expressions. But until then, goodbye.